Dear students, in this presentation, we will be discussing another data structure called string. Here, you see different terminologies that are used to get more details on string, how to store string, what are the different operations that we can perform on string. These I'm going to explain in this presentation. Pattern matching algorithm I'll be taking in future days. How do you define a string? As we have seen earlier, string is a sequence of characters, but there is a special character at the end of the string that is called null character. That character is called null character. It is also defined in this way: finite sequence of zero or more characters. A string with zero number of characters, no characters in the string, whose length will be zero. We call that as null string. Number of characters in the string is called length of the string. Here we use double quotes to represent a string. To indicate joining operation, joining of two strings, we use two slashes. It is not particular to any particular programming languages. Generally written, two slash indicates concatenation or plus indicates join operation. Okay, this is an indication of join operation or concatenation of two strings. Example: suppose examples is my string. The length of the string is 8. You can see 8 characters enclosed within single quote or double quote. Here I use single quote: 1, 2, 3, 4, 5, 6, 7, 8 number of characters. Length of the null string is 0. I don't have any characters here, but there is a special character called null character. Length of null string is 0. Two strings are concatenated. Two or more strings are concatenated. Example for string. My first string is example. Second string is for. Third string is string. These three strings are concatenated. To perform that operation, two slashes are used. Example slash slash for, that is joined. To this last word is joined. The result is example for string. As you can see, there is a space. Everything is retained, but they joined. It produces the resultant string. Next, how to store string in memory. What are the different ways to store the characters of the string? Here, each of the line are treated as records. Suppose if you take a computer screen, we can have up to 80 characters, 80 columns. Once we reach 80 columns, we are going to display everything in the next row. That first row is considered as a record, but here number of columns in that first record is fixed. Sometime we may fill with the character, sometime we leave as it is. In the same way, each of the lines are treated as records. The length of this record is same. We can have characters or sometimes no characters at all, but this is fixed. For this example, I'll be taking three lines, three records. The first line is string space is space. The second string is space array. of spaces. And third case, third line, spaces, characters, space. How that is represented? We follow now fixed length format. We have to reserve that many number of cells for each of the record. Go on story of these characters. First record is string space is, leave as it is, because this first row is fixed. First row is fixed. These are all unfilled. These are all unfilled portion of the first record. The second record starts with null blank character spaces 3. ARRAY space off. This is unfilled. Beginning and ending can be left as it is. Okay, but these middle spaces are the part of the string. Third record is spaces characters. Okay, this is a fixed length record. Few observations that we can make from this is, see, this much space simply wasted. We can shift the characters to the left side so that this can be utilized for other. As we have used static declaration where the length is same, we find wastage of memory location. Now, I want to insert one more row here. Is it possible for me? Whether insertion is easy for me, it is not so easy. To insert, it is very difficult because we have to create new record, then we have to shift all the records to downwards or upwards to make room for the new record. Then I have to insert, which is very costly. Which is very costly. Suppose to insert record in the beginning place, I have to shift all the records. If there are n number of records, all these records have to shift downwards to make spaces for that new row to be inserted. It is that leads to wastage of time. So that is difficult and that leads to wastage of time. Now what are the other ways? The second way is that use of pointers. This is same. This fixed part is same, but you make use of pointers. The first record, the second record, third record. Okay. Now to insert new record, that is easy. You just create the pointer. Only you do some kind of modification to this array. Okay. You have to point second one to that newly inserted record, then as it is. It's somewhat easy compared to the previous one. This dynamic memory concept if used, that saves my time. It is not that much of difficult, but as you can see, there is a wastage of memory. To read a record, I have to read all the things. Okay, so these are the disadvantages of dynamic memory allocation, which uses fixed length record. The third one, as you can see, these are all my records. Each record is ended with a dollar. The dollar indicates null character. Okay. See, this much space is utilized for other purposes. This is utilized for other records. The characters are shifted to the leftmost. That we don't find any wastage here. That wastage is minimized. Even insertion of record is also easy. Okay, these are all the two current records. I have to insert array of record in the second place. It is easy because I need to create one more entry here, second entry. Only have to shift this much. Okay, so create one more entry, point to that new one. So that is easy. Insertion is easy compared to the previous type. Okay, the next record, next way of representation, not just use of the pointers. Okay, also store the length of the first record length of the second record, length of the third record in one of the field. Now our pointer has got one more field called length field just to store length information. How many characters are there in that record? How many characters are there in that record to that can be stored in this field? Again, as earlier, wastage is minimized, easy to maintain, and one extra information is stored here, that is length of each of the record, length of each of the line, number of characters in each of the record. Next way of representation is just like linked storage. It creates a linked list. This is a node. That node has got one information part, other one address part. This address part holds the address of the next node. Address part holds the address of the next node. The information fields holds each of the record. Each of the record. This is my current information. Now I have to insert one new record. How that is possible? We'll take some XYZ as my string. I have to insert this in the second place. For that, what I have to do? I have to create one new node, store that value. Okay, this is my link field. This link field here upload should not refer this one, but should refer this one. The address of this node must be stored here. Address of this must be stored here. A link and break this link. See how much it is easy. That insertion is very easy in this case. In case of linked storage, insertion is very easy. Even you can delete. Suppose this node to be deleted, what to do? Don't simply delete it. Before deletion, you put the address of this node here. Then you break this link. Then you break this link. So insertion is easy. Deletion is easy in this representation. What are the different operations that we can perform? We know that we can find out the length of the string. We can find out part of the string, substring, or we can find out the string in a given original string with the place. Those are the operations that we discuss here. The first is substring. So we are extracting part of the string from the main string. These are all the ADT. Suppose substring is my function which takes main string and from where you have to extract initial place, how many characters that you have to extract, length of the characters. Substring will be generated, substring will be returned whose length is length from that is extracted from this position. We'll take an example. Suppose I want 4 characters starting from 0th place. This is my 0th place. 4 characters I want. 1, 2, 3, 4. 4 characters are extracted starting from place 0. That is the resultant. We call this as substring because it is extracted from the main string. That operation is substring. Substring that requires the main string position, number of characters to be extracted. Second operation is indexing. We are going to find out a string. We call that as pattern. We are going to find out position of that pattern in the string. For that, we have to pass two information where you are going to compare original string. What you are going to check? Pattern. If this pattern is there in the string, then it returns the first character of that pattern placed in the main string. We'll take one example. Data structure is my input string. Structure is my pattern. So structure is searched here. Structure keyword, structure pattern is searched here. If there, what is the first occurrence? That first character, yes, here. This is the thing because the structure is in the main string. The first character, that index of that is here 0, 1, 2, 3, 4, 5. 5 is the index. Indexing is the process of finding position here in the main string where a pattern P first appears in the string. First appearance of the pattern in the main string, that position is returned. Okay, that is indexing. Index, the function is index, which requires two parameter, one the source string, other one pattern string. Third is concatenation, joining of more than one string. This symbol can be used, slash symbol can be used, two slashes. Suppose s1 is my string, s2 is my another string. How these two are joined? S1 and S2 are joined. The S1 is the first part of the string in the result. S2 is placed after S1. S2 is placed after S1. The length of the string, number of characters in the main string. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 number of characters. You have to find out, you have to have a counter which will start counting. You have to start counting from the 0th character till the last character. Null, no need to consider. That is about length. Different functions that discussed here are extracting a pattern, extracting pattern from certain position with a certain length, finding out pattern, concatenating strings, finding the length of the string. Next, concatenation. Equivalent C program can be written. This is a part of the program, not the complete one. We'll take str1 as my string, str2 as my second string. This is str1, this is str2. I have to concatenate. At the end, I want data structure. The first step is to copy. First step is to copy all characters of main string, or I can say I'm going to join str2, str1. These are joined to str1. For that purpose, I have to go to this place by skipping each character till the end of the character. No, I have to skip I. Is it null character? Is it null? My first character I equal to 0. Character is D, which is not null. Go to next I. I equal to 1. Character is A, which is not null. Increment I value. I value is now 2. Character in that place is T, which is not null. Go to the next character. Next place 3. Third index character is A. A is not null. Go to next character. Right now we are here. We are here. Then in the next step, you have to repeat from the first character of the second string till the last character. J value start from 0 again. J value 0. The character in the second string, first character of the second string, yes. Is it null? No. You have to copy to str1. str1. Okay, this is 1. S is copied. As you can see, S is copied. To the fourth place, fourth index, str2 character is copied. Okay, after that, increment I and J value. I is incremented, J is incremented. I is incremented and J is incremented. I value was 4, now it is 5. J value was 0, now it is 1. J value 1. The character in the next place, T, which is not 0, not null. Copy that T here. Increase J and I. The next character R, not null. Copy that R. Sorry. Next, increase I and J. Go to the next character. Index at J equal to 3. U. Is it null? No. Is it no? It is not null. Copy that U comes here. Go to the next character. For that, I have to advance I and J 4. Advance I 8. My next J value is 4. Fourth character 0, 1, 2, 3, 4. C. C. Which is not null. Copy that here. Increase I and j. J value is 5, I value is 9. Go to the next index. J equal to 5. Character is t, which is not null. Copy that t here. Increase value of j 6. Increment the value of I 10. Now we are here 10th place. That is the purpose of I. J purpose is to retrieve. J value is 6. The character in that place is U, which is not null. Character U must be placed in ith place here. Increase the value of J 7. Increase the value of I 11. Seventh character R. You have to copy that to this place. Why? Because it is not null. Next, increase the value of J 8. Increase the value of I 12. Next, the jth character E, which is not null. Which is not null. Copy that to the result of the string 1. Next value of j 9. Next value of I 13. Is j or next character of j is null? Stop that process. Stop that process. So at the end you are going to put one null character. This is how concatenation works. The length of the string. I don't know number of characters in the string. I will take now for example structure as my string. structure as my string. To find out the length, I have to start from 0th index, I value 0. Is it null? No. Now, current temporary intermediate length is 1. Update the value of I becomes 1. The next character t, which is not null, length is 2, I value is 2. Second character index 2 r. Like that you repeat till the end. Once you reach null character, that means it is null character, return that length 9. As you can see, there are 9 characters. S T R U C T U R E 1 2 3 4 5 6 7 8 9. Total there are 9 characters. Return it. You can return it. This is an incomplete program. You can do any other operation like printing. All those you can do it. Then word processing. We can insert new word into the string. We can remove a string and we can replace existing string. The first one is insertion. Process of inserting a string in the middle of this text need not be middle, can be at the end also. Now, this is my string. I want to insert st. Where? At 6th index. 0, 1, 2, 3, 4, 5. The 6th place, this string is inserted. After that, remaining character. So after inserting st, other character of the original follows. The next is deletion. Here, from that DATATRUCTURE, I have to remove TA. Which TA? Index 2. Index 0, index 1, index 2. Okay, this I have to remove. TA starting from index 2 I have to remove. After removing, the answer is DATASTRUCTURE. After deletion operation, the last one is replacement. In this string, DATATRUCTURE, replace ST by ST, uppercase ST I want from index 2, index 0, index 1, index 2. Okay, I have to replace it by ST. That TA has to be replaced by ST, remaining as it is. Okay, remaining as it is. First we'll see how to perform insertion. For insertion, we need 3 information. One, which is the main string, from which position you have to start inserting. What to be inserted? Okay, this operation inserts string yes in text T from position K. T, K, and S are the three parameters to send. Here we will assume index equal to 1. The first character index is not 0. Here we will assume 1. Okay. Now this is my string data structures. The position that you have to consider is 3. The string to be inserted is to TA. I told I'm assuming index equal to 1. 1, 2. Here I have to insert after DA, that means we are breaking the string into two parts. One is DA part, that means characters before the position, then characters after the position. These are the characters before this position. 3. DA. Then you have to insert the pattern TA. Then characters after the position again you have to join. It is a joining of three strings. Part of the first string, pattern, part of the other part of the string. Okay. Now this involves three steps. What you have to do? First you have to extract a substring before the position, as I told. From data structure I'll drop these all the things. First I have to get a substring before the position K. What is the K value? 3. So before K, before 3, 2 characters. That means 2 K value is 3, 3 minus 1 is 2. 2 character string starting from the first I have to extend, that is DA. I have to get DA, that is a substring. Okay. Next, I have to concatenate that with the pattern TA. Next, I have to join remaining part of the string. From where I have to start? From this position till the end. One string, second string, and the third string. These I have to join. Substring 1, then TA. I will be taking that as 2, and part of the main string 3. If you concatenate these 3, that gives you the operation insertion. How to write that program? So insertion, that is inserting S in T at position K is equal to join operation. What to join? Three strings you have to join. Okay, you have to join the first part of the string, substring. Second yes, third is another substring. These you have to join. Okay, it is shown like this. Something is missing, that I'll correct it. Okay. For this now, for this I'll drop this first. Raise this. Okay. The first is here part is missing. I'll correct it. Okay. Substring, from where I have to extract? From main string T I have to extract. What are the characters to extract? Starting from position 1, how many? K minus 1 characters I have to extract. In this data structure, I have to extract 2 characters because K value is 3. 3 minus 1 is 2. Starting from first position, I have to extract 2 characters. So TA is extracted. Then I have to join TA. It is my pattern string T. Pattern string T. Next, I have to extract remaining characters. How to extract? Substring from T, position 3. How many? Length of the string in that, these you have to subtract. Length of T minus K minus 1. K minus 1. Because earlier already 2 characters extracted out of this data structure. Already 2 characters extracted. Now I have to extract only these many. If there are 10 characters and K value is 3, that means 2 characters extracted. 10 minus 2. 10 minus 2. So that much you have to, from the length 10. Length of the string is 10, say, minus K minus 1. because here we extract k minus 1 characters, k minus 1 character to this is that one from the total length minus k minus 1 you have to extract. So by extracting that now we'll get structures. Join all together. First two characters, substring, remaining characters. That is the answer. Next is deletion. To delete, we need how many characters to delete, from which position, from which string. These are the three information to send to the function. Main string T, after deletion, substring is of length L, starting from position K. Again we assume that index equal to 1. This process involves these steps. The first step, initialize initial substring of T before K. For that, you have to find out the substring in the main string. For that, we know that for that you have to apply index function. Once we apply the index function, we will get the first occurrence, the first character of the substring in the main. For that, index of T comma P. Index of T comma P. Okay. Next, if this, oh sorry, the algorithm to delete every occurrence of a pattern P in T. I have to send pattern and the text T. First, I have to find out this pattern in main string T. Okay. K if returns 0, what that indicates? That means the pattern is not there in the string. If this function returns 0, that indicates that this particular pattern is not there in the string. This particular pattern is not there in the string. In such case, k value will be 0. K value if not 0, that indicates that pattern is there in the string. But where? At k value. K is the position. Again you do it. Repeatedly you do it. Till you get k value 0, you do it. At the end, display the answer. We'll trace that. Suppose stringing ing is my input. String is my string. I have to delete all occurrences of ing. Stage number 1. Step number 1. Find out k value. How to find out? Index of main string, pattern string. Finding ing in the string. Where is it? If matching, what is the position? Yes, I not matching. T, I not matching. R and I not matching. I and I matching. N and N matching. G and G matching, and no more character. That means the first occurrence of that character, first character of that substring here at position 4. So k equal to 4. Apply deletion. Apply deletion. Delete that string. After deleting, no, you will get string. One ing gone. String and remain the last ing. Again, you find out k value. Okay, find out ing in this string. 0, 1, 2, 1, 2, 3, 4. K value is 4. K value is not 0, that means pattern is there at position 4. Apply deletion. Apply deletion. What to delete? In this string, from this position, these many characters you delete it. K, length of P. Length of P is 3. From position 3, from position 4, 1, 2, 3, 4, 3 characters removed. After removing, we get str space ing. Str space ing. Again, you find out index. Index ing in the string. 0, 1, 2, 3, 4, like that. 1, 2, 3, 4, 5. This is 5. At fifth place, ing is there. Okay. Apply delete. Delete of string, comma 5, comma 3. From this place, these three characters are removed. Okay, after removing that, the string is str. Str is my string. Again, you find out the pattern in this string str. Ing is not there in the pattern. K value will be 0. K value is 0. This is repeated only if K value is not 0, but here K value is 0. Display T. String is T. All occurrence of ing are removed. The final string is str, that is displayed. Program exited. Then you have to replace. Replacement is done like this. Here in this string text, I have to replace pattern P2. I have to replace this pattern P1 by P2. P2 is the new one, P1 to be replaced. P1 pattern will be replaced by pattern P2. Take this example. Date structures is my main string. I have to look for TE. If there, I have to replace it by TA. Find out DE is there or not. TE is there. You replace this TE by TA. Answer will be TA, TA space structures. That is the answer. Steps are like this. First is to find out the index of that pattern. I can replace only if this pattern is there. If P1 is not there, how can I replace? For example, if I take XY, is XY is here? No. If XY is not there, no, what is the purpose of saying that replacement? That is not there. If pattern is there, only you have to replace it. Okay? First of all, you have to find out the pattern index T of P1. So when to replace if K value is not 0. Okay. We got now if the K value will not be 0, K value is more than 0, greater than 0, that means pattern P1 is there. Where? At K. Delete it. We know the function delete. Delete. What to delete? T in the main string from position K. These many characters you remove. These many characters you remove it. That is our T. Okay. Then we have to insert our characters, that is P2, starting from place P. For that we have to apply insert function. Insert to T from which position? At this place. Already we removed P1, so in that place insert P2. Okay. Steps are, first you find out the pattern, return the index value, remove that many number of characters in that position in the main string, insert the new string. Okay. Algorithm is like this. First is to find out the index. K equal to index of T comma P. That is the first step. Second step, the replacement. The replace of T comma P comma Q. Okay. The first occurrence is replaced. You have to repeat. You have to find out whether any more occurrence of that pattern is there or not. We are going to replace all occurrence of that pattern P1. All occurrence of P1 are replaced by P2. Again to repeat it, find out K value again. If K value is 0, stop. Display, print it. Okay. This is the thing. If data structure is my input string, date structure is my input string, TE is my pattern, TE is to be replaced. First of all, I have to find out TE is there in the string. I have to apply index function. After applying index function, that is finding T in here, T is there or not? 1, 2, here it is there. Index 1, 2, index 3 I guess. The T is there, 3. Okay, 3. At this place, that TE is here. The next is to replace. So from this string date structure, the characters to be replaced TE by TA. After that, we'll get one string date structure. Repeat this process. I have to find out, am I having another TA in the string or not. Again, you find out k value. Index of date structures, finding TE again. Fortunately, T is not there. K value is 0. Stop repeating. So we got now main string T. That is the output. That is the output. So in most of the languages, these many functions are available. One is creating a null string. I'm going to create a string which can hold up to m characters. Okay, like in C we have got char character a of 10. The main purpose of this is to allocate space for character array which can hold 10 characters. This is equivalent function in C. This will create a null string. Nothing is there. Not at initialized. String name is A which can hold up to 10 characters. But right now no characters are there. That can be created by calling null function. Null of 10 which returns a string. So here in this example, if R is a string, null of 10. Actually it is null character but it can hold up to 10 characters. Then I can compare two strings. If I take S and T are my strings, S and T are my string, data and date are my string, I can compare them. How they are compared? Alphabetically in the dictionary order, these strings are compared. DD matching, AA matching, TET matching, but A comes before E. So it is smaller one, it is bigger one. When you subtract bigger number from smaller, answer is -1. Minus. It returns minus if the first string precedes the second one. In this example, S precedes T. So the answer is -1 because data precedes date. If I pass TT or SS because both strings are same, so returns returns 0. If I pass T and S instead of S and T or SS, now I'm passing T and S. Date comes after data, so returns minus. This is bigger one, smaller one returns +1. To test whether a string is null or not, if I assume S is a string having data as characters, is it a null string? I have to test it. Is null of yes. Is null of yes. Yes is not null. Answer is false. If I send is null of R, answer is 0. Null string. This function returns integer, that is total number of characters in the string. Total number of characters in the string. Okay. Length of yes. What is yes? S is data having 4 characters. So length of the string is 4. Two strings can be joined with function concat. I'm going to concatenate S and T. Okay. I can concatenate if they are not, if at least a character there, if they are not null. Okay. Can compare that. So here after concatenation, S and T are joined. T is placed after S. Date. I can extract a part of the string from this S. From this S. How many characters? From which place? How many characters? Which place? If I consider S as my string, I have to extract 2 characters from the position 2. 0, 1, 2. Here I assumed index as 0. Starting index. It all depends on you. Accordingly, these codes will change. In this string data, I'm going to extract 2 characters. From position 2, 0, 1, 2. Total 2 characters. That means TA is produced. TA is produced. That is the result. This completes string. Thank you. Thank you for listening.